As I said, thank you for having me, and welcome everybody to this meeting. I really hope that you find some nice insights from today's discussion, or maybe I will be the one that actually has some insights. We'll see. My name is Mihaela Ghidersa. I'm a software developer at Centric, Romania, and besides my interest for technology, also I like to prepare trainings and presentations for events like this one today. So again, a really special thank you to the organizers for having me. When I'm not speaking or coding whatsoever, I like to do a lot of outdoor activities, although with the current situation, it's a bit harder to do that. I do some blogging, some reading, you know, typical developer stuff. Today, I want to invite you to join me in a talk about the subject that's been very painful for me, at least in, let's say, 1.5 years. And I'm continuously searching for the best approach and continuously trying to see, okay, what is the best. So as you already noticed from the agenda, I want to discuss concepts and approaches. Most of them are from my experiences, but also from projects that I had near me. And I'm extremely interested also in your experiences. So if you have something to share, let's discuss at the end and see how we can actually do two-way knowledge sharing. Well, we can start with something that I think a lot of us will relate to. Working in distributed teams is hard, especially when you have a distributed team, as in a part of the developers that work in the services or in the backend area, no matter how it is organized, and the part that works in the front end. Because always appear questions like, okay, what do these colleagues of ours are doing? So what those backend developers are doing, why can't they just give us the data as we specify and as we need it? And if we need to change it, why can't they just change it already? On the other side, we have the backend developers that are just questioning, okay, what is happening? What are they doing on the front end part? Why are they requesting all the time so many changes? Why can't they just say from the beginning what they need and we'll just give them? Besides from HTML and CSS, what exactly are they doing with their time? Well, regarding this last question, going a bit in time, the feeling was always that the backend developers have done the more serious, maybe smart programming. They were thinking about meaningful issues such as testability, maintainability, state management, API design, while the front-end developers were just playing with pixels and moving stuff around and making it pretty. And the reality, though, is that in the last years, at least, JavaScript has absolutely exploded. And some of the things that before were concerns of the backend developers have become the daily discussion and debates of front-end developers. So we now think in the front end as in the back end, kind of in the same issues, as in the separation is no longer valid. And the issues that we talked before, such as maintainability, state management, testing, even API design, are pretty important also in the front end area. And today we are going to talk about the application, the development team dynamics, but specifically we talk about the workflow and responsibilities, maybe in distributed teams. And when we talk about collaboration and more specific, the data that we receive from the server, the question that always arises is, okay, if we are doing a lot of things in the front end part, in the clients, if the clients are managing way too much, who will actually be harmed? Well, first of all, it'll be the developers that will become extremely frustrated for not being able to actually manage the code base anymore. Then when the need for refactoring appears, we will have some issues maybe with things like, okay, we have to slow down with the features that we are developing in order to actually give time also for the refactoring. So clients won't be happy, the product manager won't be happy. So yeah, trying maybe to actually find a solution for making this issue of needing additional data in the UI less harmful. So along the way, we had two main, let's say, not along the way, maybe for a long time, we had these two options. On one side, okay, we could just create a new endpoint and use it if something new is needed, or if we need some extra data. On the other side, okay, let's just give some new data to the endpoint that we already call. And yes, the first one, adding more data to the endpoint, we are already adding a new endpoint and using it might be a good idea if we're talking about not so complex scenarios. As in, seems that nothing is harmful, our application makes maybe 2 calls instead of 1. So it's not such a big deal. But what happens when we are doing this on a regular basis and we are adding more endpoints and more endpoints? And yeah, we will eventually end up with something that is called chattiness. And this kind of mindset usually asking for to do more and more calls instead of actually thinking maybe if we can work something in the way our entities or maybe the way we receive data can be changed. Well, we have the result is actually having a lot of adapter operations on the client. I would know because I've been there, so I know how difficult an application that uses this approach can become. And besides the complexity that we are talking, yeah, and the operations, also we will meet, or we will have to deal with a lot of network latency. On the other side, let's say that, okay, we have a very good communication with the team that is doing the development for the services that we want to use, and we need some extra data. We go to the colleague from the backend team and we are like, okay, please help me with this. Add 2 more extra fields to the response, and they are very open and they are doing this once. Nothing harmful again, but doing it again and again and again might bring an issue also in the long time, because we are going to end up with something called fat payloads. And yes, probably it's actually preferable to have fat payloads instead of chattiness, but it's not really a fair trade. So let's just look beyond. Maybe we can find a better solution. Of either of these approaches, yeah, we might have some result that maybe you recognized from working with it for a long time, maybe not. If you don't, it means that you've done a great job until now. But one of the things is actually something that is called one-size-fits-all APIs. And the thing is that we've worked with endpoint APIs for a very long time and they were great. But yeah, we have to be very careful when it comes to more complex cases, because when we work with specific and clear cases, we can use a one-size-fits-all API and everything is it's okay. But while the development in the client went a little crazy, as we talked before, the server has to fulfill a lot of complicated scenarios, a lot of specific use cases. And this is exactly how we ended up with this kind of the approach, because the APIs were trying to respond to a lot of use cases. When we are talking about web application, yeah, the way we might want to work with different browsers, and going a bit on the next level, when we are talking about the mobile version of the application we are working on, then the thing becomes even more complicated, because yeah, we can't really treat the mobile, the data that we send to the mobile as we treat in the case of a web application. This kind of APIs whatsoever are messy, they are hard to maintain and usually make us blame for REST, but in reality it's not REST. It's about the architecture and the approach that we are using when we are designing those APIs. Another issue is related to absorbing complexity. So let's say that we are not doing a lot of operations in the backend, and we are going to, okay, maybe a microservices oriented architecture, or maybe we found something that makes everything more smoothly, works smoothly in the server. And yeah, in there we might have an easier way to actually dealing with several cases. But what is happening when we have a lot of data to consume from different clients, and when it comes for different clients coming from different sourcing and trying to actually fit it to the requirements, well, in this case, we like it or not, we are ending up with some logic in the client. So the client becomes responsible for a lot of complexity and adapter operations. And I'm just asking, isn't this maybe an issue that our APIs are not checking one of the most important characteristics, which is actually absorbing complexity? Well, at this moment, it feels natural to feel a bit stuck, and yeah, we might realize that we are driven by some constraints we hardly have control over. But what if we change a bit the perspective? Because let's look a bit in the client part. Basically, we have the front-end developers that are the closest to the users, yeah, and they know exactly how the user maybe interacts with the application, what the needs are in order to actually create the interface as user-friendly as possible, and making it working with everything that is happening in there. So I'm thinking, would it actually sound that crazy that front-end developers build their own servers? Would it be an issue to do that? Well, seems like actually there is a bit of history about this. No surprise, we are going to start with the Backend-For-Frontend pattern. And before actually diving into details, two of the most popular representation of this were at Netflix and Soundcloud. And they started with actually at Netflix, they were trying to do a complete redesign somewhere in 2012. And they realized that, okay, we have to, the way we have it right now organized is limiting, because they had the traditional one-size-fits-all APIs. So they thought, okay, since we are rebuilding everything, how about think about the fact that we have to actually work with a lot of different devices. And this means a lot of fallbacks for each and every single one. So again, this means very specific use cases. And the most effective solution seemed at a time creating a layer between the client and the server. And in that layer, precisely, the client could specify exactly how to shape the data in order to be consumed by the client. So they actually worked with this approach, and it seems that a responsibility that came from the server was somehow taken by this layer, which is gathering the data. And basically, it's gathering the data and shaping it in the way that the client developers need it. So we give some control in the client side, and letting the team to actually build their own client adapters and the way they actually want to shape the data in the end. The same story happened also in the SoundCloud. They just realized that, okay, we need some new features, and we are not really able to implement those requirements. So we have to think about the change of perspective, because they found themselves in the situation where they had to actually rewrite some stuff. So it wasn't that fun. And the solution again will sound very familiar. They decided that each case would get its own API server, this own layer, as we mentioned before. And this way, developers had the freedom to optimize some very specific cases without needing to worry actually about other cases from other devices. And the name of the pattern, of course, became Backend-For-Frontend, or BFF, because yeah, it's easy to actually at first sight to think about best friends forever. And leaving aside the irony, maybe it is a way to actually create a friendship between the server and the client, or at least between that layer and the client. It may go like this, because the goal of this pattern is to actually decouple the front-end apps from the back-end in whatever shape it is. So the BFF is all about building a layer that meets the exact needs of a specific client. This is one of the core principles. And if it is to actually look a bit and make a comparison, yeah, between a traditional front-end and back-end separation and what it means to actually work with the Backend-For-Frontend in order to enhance the idea. Let's look at this specific case. Basically, in here, the issue is about the number of requests, and that since the services are created in a very generic way, yeah, it's very hard to actually be able to fit the needs that the client has. So in the end, we end up with some very bloated payloads. So a result that it's very hard to handle. I work with this kind of approach, and it's really hard to work with, especially if, as I was saying, we were working with very generic and specific services. So from that part, we had no chance to actually receive some understanding at a time. So in the end, the front-end team had to do a lot of workarounds and create a lot. These workarounds in the end created a lot of issues. So basically, why it seemed that BFF, or an approach that it's similar to a BFF. Of course, we don't have to do a full BFF, and we will discuss later. But what exactly we want this BFF to do is to help us in actually providing only the data that the client needs, nothing less and nothing more. So help us to actually do this. We have, of course, increased a better response time, to build some resiliency, yeah, because I need to actually be sure that my application actually I can extend it, I can work with it, I can add devices maybe, I can work with different cases and different scenarios, and of course to be able to trust the caching process and reuse as much as possible. This also comes with the performance. Looking a bit maybe at the structure and what we've discussed until now, you might think, okay, but this is a point where we are actually gathering some services. So how is this different from the API gateway? Because they both seem to have pretty much the same objective, as they are trying to decouple the system services from the clients. The client doesn't need to know about the services location, and yeah, create no dependency on the communication protocol. And if we take it from scratch and talk about microservices, as API gateway and the Backend-For-Frontend pattern are two patterns that serve microservices architecture, we can simply conclude that both have as a scope the creation of reliable solutions that make the architecture we are trying to build, or that we are trying to be aligned with, yeah, and the entire actual administration of what it comes to processes become more efficient and less expensive. This is what every architect, I guess, is dreaming about, or maybe project manager. So basically, we are working in the same area when it comes to API gateway and BFF. But let's just look a bit at the representation when we are talking about the API gateway. Yeah, this in this case, the API gateway does not distinguish between client types. So if I want to add another type of client, let's say I want to add a mobile version of the application, it might be a bit tough to actually work with an API gateway. Because in this case specifically, yeah, the API gateway is a single point of failure and a single point of entry for all the clients actually. As I was specifying, I worked at some point with the project where if having all the clients go through the API, all the services going through the API gateway, when the API gateway was failing for the cases are not important. Why? Yeah, the application was kind of besides the fallbacks that we had, they were some kind of useless. So going back to the advantages that we talked about that we expect from the BFF, and again putting the finger in the in the area that hurts the most, which is actually giving specific data to different types of clients. Well, while an API gateway is a single point of entry, as we were saying for our clients, a BFF is responsible for a single type of client. So let's assume that our system has two clients, the single page application and a mobile, maybe, it doesn't matter if it's IS or something else. Well, in this case, each client would get its own API gateway, which in this way, we are actually building that BFF that we were talking about. So let's look a bit at representation in order to get a bit more details in this area. So basically, this is how it would be. Yeah, I have a web, I have a mobile, I'm building the BFF for each. The biggest difference in BFFs and traditional approach that we've discussed, so the two images maybe, is that the client no longer calls the generic backend, or how someone expressed at a time, and it felt really funny. In order to make a statement instead of generic, he said, okay, this is a universal backend. Well, no longer trying to get the data directly from there. Now the access is made through this middle layer that we were discussing. And in this way, each client will have its own BFF specific server. And we are going to do in here all the processing that it is needed in order to avoid the UI logic, and also avoid those a lot of calls between different services when it comes to actually aggregating some data, maybe trying to give some specific, more specific results. So maybe you are going to think in this moment, okay, so basically I have two options that are not very different. I have the API gateway on one side, I have the BFF on the other side. How do I make, let's say maybe in the beginning, I don't know exactly if I'm going to have I don't know, different kinds of clients, or maybe as my application develops, I want to think about the approach. How am I going to make the right choice? Well, first of all, I think we have to think about, okay, how different are the needs of each client if we know about what kinds of clients we'll have. Normally, it would be nice to have the information from the beginning, but if we don't, we can actually migrate to a BFF approach also later. So it's not an issue in this part. Yeah, we can migrate it step by step. Another question might be, okay, do we need to support different communication protocols, as in maybe I am in this point where I use the REST for a very long time, and now I'm trying to step by step go from REST to using the GraphQL. In this case, maybe we can also go on the BFF approach, because it's more open to actually creating those servers that actually can help us aggregate the data as we want and not influence the other sizes of the application. Plus, that GraphQL is actually coming with a lot of perspectives and advantages on the aggregation of data per se. Then we have to think, okay, maybe if the clients are owned by different teams, because if we're working in distributed teams, as we open the discussion, well, in this case, we might need to use the BFF approach, because many times we don't want components with shared ownership in a system, no matter what kind of it is. As in, yeah, if I know that I have backend, I have the backend, maybe it's separated in a lot of services teams. Then I have the UI that is consuming. Maybe I have the UI for the web application. I have the UI for the client. Yeah, it's better to actually keep it very clear. And a BFF approach might be more helpful in this area. Other things that we are going to, or maybe specify, is very important because we are talking about aggregation. Well, we also have the possibility to do some aggregation in the API gateway. So we just have to be very careful if we want to, or maybe it's the company policy to actually use an API gateway. Maybe we can at least choose what kind of API gateway to use in order to have the aggregation option, because yeah, there aren't a lot of instances of API gateway that we can use that comes with this out of the box, or maybe create your own if you feel creative and your project has the time to do this. So there are different questions like this in order to actually make a better decision, and I'm sure that with experience a lot more appear. But even though we've kind of discussed about the BFF pattern and we expose all the good things that it brings, it's important to understand that everything that we are discussing today has costs, and especially if we use a tool in the wrong context or in the wrong way, well, it can become very harmful. So when it comes to the BFF, there are two concerns. One is the duplication, because let's say that we are using these distributed teams that we are talking about, and yeah, it doesn't matter how much we want to think that, okay, everything is so well organized and the communication is great. Well, reality though is a bit different. So we might end up at some point with some duplicated code in two teams, let's say, I don't know, some operations. Well, in this case, I find it very important to do maybe knowledge sharing sessions, or have a very good technical ownership and technical leadership in order to be able to identify this sort of situations, and to actually use the opportunity in order to create a shared library and get certain functionalities developed only once. On the other side, it might be that, okay, we have more services, yeah, we have more components. So what is going to do in the deploy part? Well, there isn't a very, I don't know, a very specific way with some very clear and well explained steps on how we can do this, because it depends a lot on in what point the application is, what the tools you are using in the context of the company that you're using, or the experience of the team. But I think that this issue actually can be resolved with a very good DevOps team, and a lot of ownership when it comes to ownership and monitoring, also when it comes to the DevOps teams. And yeah, have someone that actually has a lot of focus on the quality of the releases, and actually is able to make the most of it. So I came to see, or to know in the last years, that a DevOps team can have a very important perspective when it comes to the way the application is organized, because they can see a bit beyond the architecture and the way we are developing. So we are so caught up in our work that we forget to actually think about how we are going to deliver the application to the clients. Okay, so basically in the Backend-For-Frontend area, as in the basis, so this is the areas where it shines, but we are talking about also about GraphQL as an aggregator. So yeah, we've talked about the benefits in the BFF, but how about we think a bit how GraphQL can give us some of its advantages in order to actually be able to build what we need without with less effort. So basically, well, yeah, the BFF gives us a lot of modularity. We need to be aware that there are still some points that need special attention in the idea that these interactions and dependencies need a clear way to actually serve different clients. And a way to do this is actually integrate or maybe use as your BFF the GraphQL approach. So what it has behind. I'm not going to go very much into details because related to the details of GraphQL. What I can say is actually that as a bit of context, that it started at Facebook. They were thinking about a way to reorganize the way they were working with the APIs. The problem was actually that they determined that there were a lot of differences between the data they wanted to use and actually the data that the server was returning. So again, we have sort of the same issue if we look from this perspective. And they identified that there was a lot of code that they had to write, both, so complexity, both on the server and on the client in order to prepare the data and then parse it and use it in the client. So basically the same frustration as we discussed before. So long story short, what does GraphQL do? It provides declarative ways for the UIs to actually interact with very specific data, with the data that they need in a very specific way, actually. The data is shaped by some resolvers that is part of the API of GraphQL, and the UI just specifies what it needs, and that's pretty much it. Simply put, when we talk about GraphQL, we talk about the query language, and on the other part, or another very important part, is the schema language that actually help us to create those queries. So if you work with it or if you are curious about it, I guess you'll find it very different and interesting at the same time. The cool thing about the query language is the fact that it allows us to fetch just the data that we need in a very specific and efficient way. So just what we discussed also as a need when it comes to the BFF. Going to complete the context is the schema language, where we can define what queries we have, what mutation we can access, define, and actually also see. It depends on which side we are looking, from the person that is building the server, with GraphQL, or from the client perspective. So with GraphQL, we are using exactly the queries that we need in order to get exactly the data that we need. And this is happening in a single request. The client controls all the data that is required. And of course, you are requesting, having into mind exactly what the server is giving you. So GraphQL is organized in terms of types and fields. We don't have so many endpoints as we were actually using in REST in order to get full access to all our data capabilities. We are doing this only by using a single endpoint. And since I mentioned REST, it's important to to again mention and underline the fact that this is not a debate between which one is better, but more like a matter of selecting the right tool for a specific job. Because, well, GraphQL APIs help avoid both underfetching and overfetching of data. And yeah, they provide with build data validation, and they have this thing that is called introspection that is documenting everything that what we are doing. Well, REST has been around forever and has a super high adoption rate with a lot of well-known conventions. So yeah, we've been using it a lot. There are a lot of big applications that are using it still. So it's no debate. It's just a matter of, as you can see, some specific capabilities that help us choose the best one for the case that we are in. A bit of visual regarding the part with the endpoints. We are talking about doing some requests in order to actually gather some data that it's related or working together in a REST approach. And then we are looking at the GraphQL, where we can just define that query and see exactly what resolvers we have available and what we can do. So basically, GraphQL server takes a query and returns a response of the same shape. If we look a bit on how it looks. A very nice joke, actually. This one was, and I really wanted to add it. It's the fact that, okay, REST is somehow the equivalent of a restaurant saying, okay, what do you want? We'll give you what we have anyway. So that is important. But again, something that it's not out of the box when it comes to REST, but it is for GraphQL, is actually that introspection part, where you can see exactly, as we were looking, you can see exactly what you have defined for this, from the server in order to do the operations that are available with all the specification to types, to return type, and so on and so forth. So it's really helpful, especially when we are talking about, and I can give you an example that I had, a team that actually we were working on the UI from a different country from where the backend was. And the communication is even more difficult when you don't know personally the people you are going to collaborate with. And having that introspection part available and seeing the documentation of what the backend was doing helped us a lot. So maybe we can go to the idea that GraphQL could be our BFF, as in combining both of them, because we can think about having a complex system with a lot of REST services, and I think I already mentioned this case. So a lot of REST services. The services are used by several clients. And maybe at the level that the application is at the moment, I don't have the time or the resources to change them all. And at the same time, I really, really want to optimize the way I'm retrieving data. And I'm trying to actually use the best of both worlds. And we can think of something like maybe migrating the services to the BFF one by one, even either doing it for the services that are already built in, or maybe for the new services, or some that I think, okay, I want to migrate at this moment. They will not bring complexity in the application. We can do this. We have the resources. We talked a bit about the capabilities of GraphQL in terms of what it means, retrieving data and so on. But I really want to give an eye to the areas where it shines in order to understand the benefits, maybe a bit more than just, okay, it's user-friendly and the development processes works very good. But first of all, at an architectural level, I think it's very important the fact that the client gets the freedom of receiving the data that actually wants, the fact that it gives us the possibility to serve several clients, the fact that if I'm changing a client, it doesn't mean that it's going to impact the other ones, so I can work with them independently. Yeah, and then working with the clients independently, also the teams can work independently. So a lot of advantages in this. And again, it might sound like, okay, in this case, do I really need a BFF? And a very nice feature of GraphQL is the possibility to interact with data in a very specific way, as we discussed. And for a while, concern was that the GraphQL couldn't replace the BFF completely because, okay, you know, we have the need to respond to different types of clients, and yeah, they have their corresponding models. So maybe the operation schema would become overloaded and hard to work with. So is it really a good idea to work with this? Where I guess all these questions were listened to by the guys that were working with actually expanding and improving GraphQL, because yeah, now we have, or in time, we started to actually have the possibility to make schemas or make structures more reusable by introducing the NPM modules, something that is called partial. So yeah, whatever you choose to work with in the end, if it works for your case, for your application, for your specific approach, just choose. Even if you want to go with GraphQL, if you want to go with the BFF, the API gateway, as we discussed, it's a matter of choices. In the end, I would like to maybe leave you with a bit of change in the mindset, because for a long time, as we opened the discussion, was that, okay, we have this separation between the server, the backend and the front end, the client and the server. And we were just, okay, the limits are very clear, and this is what it should do. Well, actually, as we can see, we can actually step a bit over the line and understand what is happening, and maybe work from the perspective of a backend developer in order to understand how the data interacts and how to shape it. Another recommendation would be that, okay, you don't have to be the know-it-all of the whole stack. That's almost impossible. But it's nice to actually look a bit beyond what we are working on a daily basis and try to understand a bit the other side. Even if we're talking about DevOps, we are talking about development in the backend part and the services. Yeah. If on the other side, we are talking about what exactly is happening in the client side, it's better to have an overview, because in this way you can actually, besides being more understanding with the other teams or the colleagues that are developing certain areas, also you can understand exactly how to shape your work in order to create in the end, because at the end of the day, yes, we have to build a quality-oriented product that is performant and goes well with the requirements of the client. I really, really hope my words today mark an interest point, and that your curiosity was triggered in order to maybe go a bit beyond and look more into this. And maybe just, if I gave you an idea about what is happening, it's just so nice for me, and I'm very happy. Baseline is the fact that there is no silver bullet or golden hammer. We shouldn't be looking for the best approach, the best steps that help us with actually checking an issue that we have in the application. We have to do research, and I came to know that even the best tools in the market, if they are used mechanically and without actually understanding what is happening behind the curtains of that tool, well, it can be pretty damaging, and yeah, we'll just end up crying about it on all sorts of forums, saying that a tool is just not cool, but we are not really thinking about how we were using it and if the context was okay. So choose wisely, research, and go with the choice that gives you the smallest cost and the biggest win. Thank you very much.
Thank you, Mihaela. Thanks for giving an overview about GraphQL and Backend-For-Frontend design pattern. So if you have any questions, feel free to ask Mihaela. And you can always reach out to her on Twitter or LinkedIn if you have any further follow-up questions from this talk.